Okay, so last year we focused on three trig ratios. What are they? Sine, cosine, and tangent. I'll just write out the full names for them, but of course we always refer to them as sine, cos, and tan, just like you said. And to remember, and each of these represents an operation that we do to an angle. Okay? And what does it do to that angle? It finds the ratio in a right triangle of the side opposite or adjacent to that angle to the side opposite or adjacent or hypotenuse. Okay? And we remembered those trig ratios using what? SOHCAHTOA. So therefore, and then now that we remember SOHCAHTOA, how do you find the sine of any angle? It's always what? The ratio of its opposite side over the length of the hypotenuse in a right triangle. Cosine of an angle is the side adjacent to that angle in a right triangle divided by the hypotenuse. Okay. To find the tan of an angle, we take the side opposite that angle and divide it by the side adjacent to that angle, or it's the ratio of the opposite side to the adjacent side. Okay. But we're dealing, and we use these when we were dealing with acute angles between 0 and 90 degrees, but we're going beyond that now. So we're going to need a coordinate grid to help us. Because how are we going to find the cosine of an obtuse angle between 90 and 180? How are we going to find the tan of an angle between 270 and 360? Well, we want to see it on a coordinate grid. Okay? Using reference angles, we can create a right triangle in any quadrant on the coordinate grid. Okay? So I'm going to create a right triangle in quadrant 1. Remember our angle? The initial arm is the x-axis, the positive x-axis, and the terminal arm comes out from the origin into the quadrant. So if I want to construct a right triangle out of this, I draw the angle, and then I just draw the third side so that I make a right triangle. Okay? Let's say that this is a point in quadrant 1. Doesn't matter what the values are. We'll just call it xy. Okay? Remember, this is the angle we're focusing on, so I'll call it theta. If I said, don't write this down, but if I said the point was 3, 4, could you tell me a side length of one of the triangles that I drew? Which one? Which one is 3? What does 3, 4 mean? What do I do when I plot 3, 4? Starting from the origin, where do I go? No, come on. To the right 3 and up 4. So wouldn't you all agree that this is 3? No, you did not. And this is 4. You heard me. So if I know a point, and the horizontal side of the right triangle will be x, the vertical side will be y. If I know those two, can I find the hypotenuse? Using what? using Pythagoras, right? And if you found it in this case with these points, you get 5. Because 3 squared plus 4 squared is equal to 25. Square root of 25 is equal to 5. Okay? So instead of using numbers, if this is the point xy, this is always going to be the value of x. This is always going to be the value of y. And this is going to be the hypotenuse, which when we do trig with this, we're going to call r. There's a reason for that when we get into the unit circle, because we're going to draw a circle on the coordinate grid. And what do you call a length that goes from the center out to the circle? A radius. Okay? So that's why we're going to use r. So we're going to rewrite each of the trig ratios in terms of x, y, and r. You told me that the sign was opposite over hypotenuse.
Yeah.
What is the name of the... No. Y. Opposite over hypotenuse. Stop focusing on the point. It's the angle.
Oh.
Next. Cosine. Adjacent over
R.
x over r. Tan y over x. And because we were in quadrant 1, everything was positive. Okay, so all these are positive. But if I start drawing right triangles in quadrants 2, 3, and 4, I'm going to get some negatives, which I'm going to show you now. If you have 4 different colors, that might be helpful. Okay, so just to rewrite this, if we drew a right triangle in quadrant 1, if we're dealing with an acute angle, this is y, this is x, this is r, okay? And in quadrant 1, sine theta is equal to y over r, which is a positive value over a positive value, which is positive. Cosine x, or cosine theta, is equal to x over r, which is a positive value over a positive value, which is positive. And tan theta is equal to y over x, which is a positive value over a positive value, which is also positive. We've dealt with all these before. Any angle in quadrant 1 that we make a right triangle of will be acute angles between 0 and 90. We've been working with these this year and last year. It's when we get into the other angles. What if I draw an angle, remember it starts here, and it goes into quadrant 2. How would I draw a right triangle in quadrant 2? Along the x, because I need a reference triangle. I need a reference, right? And then connect the third side. And we're going to use this reference angle to help us find the trig ratios of the actual angle. Well, what's this length? Y, again, because if we have, what's this length? But it's x, but it would be negative. And when you do Pythagoras, everything becomes positive R is always going to be a positive value. Because remember, any point in quadrant 2, the x value is going to be negative, the y value is going to be positive. Any point in quadrant 1, they're both going to be positive. So that's going to change the signs of the trig ratios. In quadrant 2, how do I find the sine of theta? Well, I use the reference angle, and I use opposite, which is y, over hypotenuse, which is r. They're still both positive for sine. I'm not using a negative. For cosine, no, negative x over r. So that's a negative over a positive equals a negative. Okay, so, and you can see this on a calculator. If I asked you to find the cosine of any angle between 90 and 180, you'd always get a negative answer. If I asked you to find the sine of an angle between 90 and 180, you'd always get a positive. If I asked you to find the tan of an angle, well, what do we have now? Opposite, y over adjacent, negative x, which means that the tan of any angle between 90 and 180 is going to be negative. The only one that's going to be positive is sine. What if I want to find trig ratios in quadrant 3, angles between 180 and 270? Well, this time I've got to draw, and notice it doesn't matter what size you draw. From here to here. Well, how am I going to find the trig ratio of angles like this? I'm going to use a reference triangle in the third quadrant. How do I do it? I draw the reference angle, which is always the hypotenuse that comes out, as well as whatever x-axis is closest. And then I finally just connect with a vertical segment to make a right triangle. So I'm going to use this angle here to find the trig ratios so I can get the actual angle. Well, what happens here? What's this value? Negative y. What's this value? Negative x. And remember, when we find the hypotenuse, we do Pythagoras, which means we square. And as soon as you square negatives, they become positive. So in quadrant 3, angles between 180 and 270, the sine of any angle is going to be the opposite negative y over the hypotenuse r, which is going to give us a negative. The cosine of any angle is going to be the adjacent negative x over the hypotenuse r, which is also going to be negative. How about the tan? Right. It's going to be negative y divide negative x, which is a negative over a negative, which actually makes it positive. So if you were to pick any angle between 180 and 270 on your calculator, if you plug in for sine, you're going to get a negative answer. If you plug in for cosine, you're going to get a negative answer. If you plug in for tan, you're going to get a positive answer. Right? Finally, what about if we're dealing with an angle in quadrant 4? Okay. Where's my horizontal segment going to be now? Along the x, so this time along the positive x, right? And then you connect your vertical segment to make a right triangle. X is now back to being positive. Y is still negative, as in quadrant 3, and R is always positive. Sorry, I should have added the points here. So this is x comma negative y in quadrant 3, and this is negative x negative y. So in quadrant 4, the sine of an angle is going to be negative y opposite over hypotenuse, which is negative over a positive, which is negative. Cosine, however, is going to be adjacent, which is positive x over hypotenuse, which is positive r, which gives me positive over positive, which is positive. And finally, tangent of theta is going to be opposite negative y over adjacent positive x, which gives me a negative over a positive, which gives me a negative. So that means all the angles between 270 and 360 will follow this. So how do we keep track of all this? How do we keep track of which one's positive, which one's negative? Because I don't want to have to draw this all the time. Okay? Well, quadrant 1. What can you tell me about the sign of all the trig ratios? They're all positive. So all. What about in quadrant 2? What's the only one that's positive? Sine. Quadrant 3, tan. And quadrant 4, cos. So there's a few ways that you can remember this. If you want to make a song, go ahead. I'm not. If you start from quadrant 4 and go counterclockwise, it spells the word cas. C stands for cosine positive, A stands for all, S stands for sine positive, T stands for T positive. Okay? If normally we start in quadrant 1, right? And we go counterclockwise. So how could we remember A, S, T, C? Well, there's a couple ways. All, suckers, take, chemistry. About 5-6 years ago, a group of grade 11s came up with this one. All snakes talk crap. Whatever you want to make up, whatever you remember. Okay? So, don't look down. Just remember, see if you can answer these. Okay? In quadrant 2, I didn't ask yet. Is tan negative or positive? Negative. In quadrant 4, is cosine negative or positive? Positive. In quadrant 1, is sine positive or negative? Positive. If I asked you to find the sine of 170 degrees, would that answer be positive or negative? Why? Because it's in quadrant 2. Good. Okay. If I asked you to find the tan of 240 degrees, would it be positive? Don't look. Would it be positive or negative? Quadrant 3, tan. Tan is positive. So it would be positive. Okay. All right. In which quadrant or quadrants is sine always positive? 1 and 2. Okay. In which quadrants is tan always negative? 2 and 4. Okay. If I said that the sine of an angle was positive and the tan of the angle, same angle, was negative, what quadrant would that be in if I drew it? Quadrant 2. Good. Okay, excellent. Here's a couple of other examples we're going to look at. I got a little excited, I lost my pen. There we go. Okay. The point -5, -12 lies on the terminal arm of an angle in standard position. So we got to draw an angle. And my initial arm goes here, as always. If my terminal arm has the point -5, 12 on it, what quadrant is that going to be in? 3, because both are negative, right? So it has to be this. So this is, we don't have to be perfect. This is the point -5, -12. So this is theta. I've got to find the trig ratios for sine, cos, and tan. I don't have to find the angles, just the trig ratios. Well, what do I need in order to find the trig ratios? A right triangle. How do I draw a right triangle in quadrant 3? Good. Do you know any of the sides? No, not yet. X is -5. Y is -12. No, we don't. Not yet. Like, where does it say R? But what's the value of R? Well, we can't, that's not finding the answer. You need a number. How? There you go. Quiet, you. So a squared plus b squared equals c squared, or in other words, x squared plus y squared, r squared. I'm not the, don't ask me. I don't need praise. So x is -5 plus y is -12. Don't forget those parentheses. Equals r squared. What's -5 squared? What's -12 squared? 144. Add those two together. What do you get?
You get.
Thank you. Now, how much do we remember about solving quadratic equations? What's r? Just square root? Whenever we solve an equation, don't we have to take the positive and negative square root? That's how, that was all unit 3 when we were solving quadratic equations. When you solve, you have to take the positive and negative square root. However, it can only be one answer, can't it? It's going to be what? Positive or negative? Why? Because r is always positive. So what you would do is this, is you would say r equals 13. But I want to see this. If you don't write this, to me that's an error. You say so. You say so. So why did I have to go through the bother of finding that side? To find the trig ratios. What's the sign? What's the sign? Opposite over hypotenuse? What's the opposite side? Sorry?
Oh, I can see it's 13.
What's the opposite side? Somebody tell me the opposite side in the right triangle. -12.
Sorry, I said 12 and maybe I made wrong.
What's the hypotenuse? There we go. That's our answer. -12 over 13. The cosine of the angle. Adjacent over hypotenuse. Sorry, Juliana? -5? Thank you. What's the tan of the angle? Opposite over adjacent. Which is -12 over -5. You can leave it like that? No, because it goes to 12 over 5. Well, she keeps bumping mine. Okay. Another example. Same kind of question, except the information is given a little differently this time. We are told that it's in quadrant 3. So right away I can do this. And I'm going to have to draw a right triangle in quadrant 3. Well, how do I do it? Negative x-axis is the horizontal side. Connect the vertical. There's our right triangle. In order to find the trig ratios, I need to know the sides. The only thing that tells me about the sides is this. Exactly. We know that cos is adjacent over hypotenuse. That means this must be -3. This must be +4. So now it's one of the legs that's missing. Yes, y, but it's going to be negative. So x squared plus y squared is equal to r squared. So it's going to be -3 squared plus y squared. I'm just going to call it y for now. Equals 4 squared. So this is slightly different. So I get 9 plus y squared is equal to 16. Y squared is therefore equal to get that calculator down. You kidding me? So how do I find y?
Plus minus square root.
Take the plus minus square root, but which one is it going to be?
It's going to be negative because it's negative y.
Y is going to be -√7 because it's in quadrant 3. Okay. Now we're ready to find the other two. Now that we've got all the sides, so this is -√7. Remember, don't go to decimal. We haven't been doing these as decimals. We've been leaving them as exact values, as square roots. So therefore, the sign is going to be the opposite side, which we just found, over the hypotenuse, which would be what? What's the opposite side? -√7 over the hypotenuse, 4. The tangent is opposite over adjacent. What's the opposite side? What's it? Sorry? Slow it down. Slow it down. Negative root 7 over negative 3. Oh, sorry, this should be theta here. Two negatives become a positive. Holy smokes.